Hello everyone. In this video, we will learn about the XRD analysis in which we will cover three important topics. In first, we will see how to calculate the peak position and FWHM, that is the full width half maximum, using the XRD data. And then we will continue to calculate how about the crystallite size, and for that we will use Scherrer formula. So to calculate the crystallite size, there are two ways. One is the very most popular approach to calculate, and there is one another approach which is quite simple. So I will going to explain both the methods, and then in the last section we will see how to calculate the crystallinity, which is peak to noise ratio. So I have shared all the formulas also. So let's start. Now let's begin with the how to find out the peak position and FWHM, that is the full width half maximum, using the XRD data. Now let's open the XRD file. Now just select x-axis and y-axis data and plot simply using line. So here we got an XRD data. Now the x-axis represent the angle, which is 2 theta, and the y-axis intensity, and it has the arbitrary unit, or sometimes people use counts, so we can use AU. Now as you can see, we have the multiple peaks. Now let us first try to adjust the scale. So for adjusting the scale, just simply click x-axis, or you can also click the y-axis and go to the scale over here. For the horizontal, it is take 10, and as you can see, we have the peaks till 80. So 80, and then apply. Now for the vertical, as you can see, the maximum intensity is around 6,000, less than 6,000, maybe 5,500. So what I'll do, we will start with 0 and maybe 5,500. Now as you can see, okay, now we got the proper XRD data. Now first, there are 2 points. First, we have to see how to fit the single peak in order to find out the FWHM. Generally, it is considered to be taken a peak which has the highest intensity. So I will take this peak. For that, what we will do, and one more thing, since as you can see, the data is very well aligned and there is no need to go for the smoothing. So simply we will go to the analysis, peak baseline, multiple peaks, and open dialog. Here we have the option peak function. So we have, for the fitting XRD analysis to find out the FWHM, we can use Gaussian and Lorentz. Generally, people use these three to get the best peak fitting. So I'm using the Gaussian for the moment. Now what I'll do, I have to select the peak, and in order to select the peak, what I have to do, just simply place the cursor on the peak and double click. So this is how our peak got selected. Now open. Now these are the parameters which it will going to use. So we have this residual. This is the formula for the Gaussian fitting. This is how the peak fitting has to be done to find out the FWHM. So what I'll do basically, we have to run the iteration. This is the single iteration, and we have to see if we have got the good fitting. But as you can see, it is not the best fit, so we can do the iteration in like this, or we can do the fit until it will converge. So as you can see, the iteration is complete. And one more thing, you have to see this COD value. The value of this COD R square, it should be close to 1. And here the value is around 0.91. So what I'll do, and you can also see it is properly fit. So I just simply go for done. So this is how we got our parameter. And let me zoom. So you can see we have the fitting, but still the curve is not properly aligned. And for the moment, you can see the position of the peak is denoted by XC, which is 38.18, and the FWHM is this W, which is 0.274. This is how you can calculate the peak position and FWHM. Now for the moment, let me zoom in. Since we have seen that it is not the properly curve fitting, so what we have to do? Just simply select the what I have done. Let me just simply double click. Simply double click and we have the files. I am selecting the original file and okay. So this is our original file. So this way what you'll do, you just simply go for the analysis and just try with the another one. Instead of Gaussian, you can use the Lorentz fit, right? As usual, then go for the single fit, double select, and value is close. And as you can see now, let me done. As you can see, let me zoom. It is exactly proper fitting of our peak. As you can see from here, it is the proper curve of our peak. And if I compare the value from the Lorentz and with the Gaussian curve, what I have found that XC is more or less the same, 38.18, which is also there, and but the W, which is FWHM, in the case of the Gaussian was 0.27, but here 0.22. So we have to take the peak function as per our requirement so that we get the best fit. Now this is a case for the single peak fit. Now if I want to pick the multiple peaks in a single shot, so what I have to do? So that we will see. Just simply deselect all the file and take the original file only. Here is my original file. Let me zoom out. Okay. Now what I have to do? Now I want that. Now if I want to find out the multiple peak position and FWHM, so what I have to do? Simply the same procedure. Baseline, multiple peak, open dialog. You have to select peak function as per your own choice. So Gaussian. Now I will select the peak which I want to fit. For that go to the page and double click. Suppose I want to do these 4 peaks and I have to find out the peak position and FWHM. Now same, fit until it is completely converged, and here you can see the every time you have to see the value. COD is 0.97 and here you can see the fitting. So done, and here you got the file where you can see the value of the peak one, its XC, W for the second peak, their value and so on. Now let me zoom. So you can see here, this is how the peak fitting is done. And this small peak. So this way you can do the proper peak fitting to find the peak position and FWHM. Right. Now one very important thing is, in case you are taking the raw data and you are just following these steps which I already told you, and then you come across that there is a problem in the peak fitting. Why? Because the COD is not close to the 1. If COD, that is the R square, it is not close to the value of 1, so then what you have to do? Suppose the value of the COD is coming around 0.04, which is not a close value to the 1. So in that case, we have to first do the smoothing of our XID data and then again do the fitting. So this point you have to make sure. So this is all about to find out the peak position and FWHM. Now we will see how to calculate the crystallite, that is the grain size, from the XRD data. And in order to calculate this size, we use the Scherrer formula. So here is the Scherrer formula. D is equal to K lambda divided by beta cos theta. Here D represents the crystallite size, which is in nanometer. K is the Scherrer constant and its value is fixed, which is 0.9. And lambda represents the wavelength of the X-ray source and it is 0.154 nanometer. Beta is the full width half maximum and it should be in radian, and theta is the peak position. Now let's see how we can calculate this crystallite size. As you can see here, till now we have understood how to calculate the peak position and FWHM. So we have the peak position value, we have the FWHM value of all the peaks. So what we'll do, we just simply use this formula and we will put the value. The K lambda are fixed, theta we can find out from the peak position, beta is the FWHM, so we can find out the crystallite size. Now there is another way to calculate the crystallite size, and for that what we need to do, let us first remove the fitting part. So this is our original data. So this is not the very popular method which I am going to tell you, but it is very effective just to calculate the things shortly, and you don't need a calculator, you simply calculate from the origin only. So what we have to do, we have to go to the gadgets, quick fit, and then we use peak Lorentz system. So here you got this window. So if I want to calculate the parameters for every peaks which are present in the graph. So what I'll do, I just use the magnifier and select the peak. Let's say this is my peak. As you can see, you can stretch the window so that it looks good and fit. Okay, now just these are the values which you got for this specific peak, the W, the theta position, XE. Okay, so just double click. Here you got these values. So what you have to do, you just simply with one single space just put the values. And okay, now what I'll going to do is copy, and I will take new workbook and simply paste. So here I got the values in the same way. Now take the next peak. I'm not taking all the peaks, I'm just taking the peaks which have some good intensity. So let us take this one. Perfect. Double click and just okay, done. No need for the comma, so simple. Copy, and here is our file. Paste. Okay, then again, now this time I'm taking this complete this. Let me zoom the peak. This one. These are the values. Paste. Okay. Now again we use the magnifier, and I'll take the 2 peaks only. Now it looks good. Now again same. Copy. Okay. Now let me quickly take the last peak, although there are more peaks present, but let me take this one. So let me reduce the size of the window. Okay. Okay. So here we got the values, the important parameter which we got. Now what I have to do? Now I have to calculate this crystallized size with this formula using origin. So what I'll do, let me take one other workbook and I will use insert this parameter. First is K, second is lambda, right? Beta, cos theta. These four values we need to calculate the Scherrer, to calculate the crystallized size, beta and theta. So finally we got the D and it should be in nanometer, and since it's a constant value it should be 0.9. Since we have taken the 5 peaks, so just simply copy paste 4 more times. And some error, I think 0.9, 0.9, 0.9 and 0.9. Okay, now lambda is also same. This will be 0.1. Copy now this theta, which is nothing but our FWHM, right? And theta should be in radian, and also this FWHM should also be radian. So now we have to take these values. As you can see, the XC in the second, the XC, first come the Y0, XC, W and A. So from here is the XC, here is the W. So we need to simply copy and paste, and in the same way, no, I'm sorry, I have pasted in the wrong column. With the theta, X is the theta, and here is the FWHM. So finally to calculate the crystalline size, we use the formula Scherrer equation. How we'll calculate using origin? Simply just right click, set column values, and now here you have to put the formula. What is the formula is? In the numerator it's K Scherrer constant multiplication with the wavelength. So we will take column multiplication with the wavelength. Just I am putting in the common bracket, and then according to the formula it should be divided by the beta, which is the FWHM, with the cos theta. Since FWHM should be in radians, so we need to use the function of radian. So here on the function just click trigonometric and take radian, and here just column beta. Now with the multiplication sign cos theta, again go for the function trigonometry cos. Now it should also be in radian. So first we have to define that it should be in radian, trigonometric function radian, and then our column theta, and it should be divided by 2 because this is the value of the 2 theta, and according to the formula we have to put the value of the theta. Apply. So this is how you can calculate the crystalline size from the origin. There is no need for the calculator. So this way you can calculate the crystalline size. Now in the last part of this video, we will learn how to calculate the degree of crystallinity, that is peak to noise ratio. And to calculate this, we have this formula. Crystallinity is equal to the area of the crystalline peaks divided by the area of all peaks, whether crystalline or amorphous. So we have to take this area so that we can calculate the crystallinity. Now let us calculate. So what we have to do? As we have already calculated from this method the FWHM, the angle, right? So as you can see, the same we will use to calculate the area. So here you can see they have given the value of the area, which is 1847 for this, but we have to consider only the peak. So let us consider each peak and see what is the area. So as per the formula, first is the area of all the crystalline peaks, right? So what I'll do, just take full area, and it is coming out to be 1841.56, right? So what I'll do, just simply write the value over here, right? Just copy paste. Okay. So this is the value of complete area. Now we will calculate the area of individual peaks. So let us take the first peak. So I'm just taking the main peaks just so that you can get the idea, because there are so many peaks, so the procedure is same for everyone. So I'm taking just few peaks, right? So what I'll do, so this is my first peak, and area is coming out to be 386. So let me copy paste this value. Now let us take this one. Okay, so it is 415. Now I am taking the most intense peak. Okay, so 2131.85. 2131.85. Now this one, 330.872. 330.872. One to 5.15. 1 to 5.15. And the last one, 142.34. 142.134. 142.134. Still, there are some few small peaks which have the low intensity are remaining, but that we have to consider all peaks, amorphous peak, crystalline peak, everything we have to consider. But for the sake of understanding, I am just taking the few peaks so that you can get idea how to calculate this crystallinity value, that is peak to noise ratio. So now what we have to do? We have to add up these values, all the values, and we have to divide the summation which is coming by this. So, just simply use the calculator to calculate the values. So first do the summation of the denominator values. So it is come out to be, so it is coming out to be 3532.64015. So you just simply divide, take the percentage, so it will be 1841.5608. So the value coming out to be final value is 52.13%. I just simply use the calculator, make the summation. So this is how you can calculate the peak to noise ratio, which is known as the crystallinity. So this is all about this complete video of XRD analysis. Thank you very much for watching.